So we're going to talk about gradient obviously. And we're going to look at how we can go about calculating, and I'm suspicious that most of us have some understanding of this already, but we're a little bit hesitant because we're seeing it in a new context. So gradient is simply telling us, well, how much does our y value change as we increase our x by 1. So every time we increase our x value, does our y value go up, does it go down, and if so, by how much? Does that make sense? We use these, we've seen them in the new equation before, we've seen that before, correct? And m represents gradient. When we're doing the tables of values, we just look for the pattern, didn't we? And that's how we got our m value. It's exactly the same thing here. Rise over run, which just means how much does it go up versus how far does it go across. Or this funky dunky looking equation here, y2 minus y1 over x2 minus x1. They're both exactly the same thing. So how many points do we need to make a line? 2. That's how many points we need to find our gradient as well. Cool? I'll explain rise over run first, and then I'll give us a go at this one. Rise over run's easier to remember, but we can have a few issues, whereas if we use this one correctly, we'll never have any problems. So if I look at this example here on the right, and I look at my black line here, I pick any point on my black line. Give me a point on that black line, thank you. Flynn. Yeah.
Yeah, 0 and 4.
0, 4? So
Yeah.
Flynn's picking this point here. I don't use red. I'll use my blue one. Flynn's picking this point here. Happy with that? Lani, pick another point.
-1, 0.
-1, 0. They're the points I would pick, correct? So with rise over run, I asked myself, well, how many steps across have I got? How many steps between those 2 points across on the x-axis? How many have I got? 1. So I run, so I'm going to put rise over run. This here is our run. Determine that's 1. How far has it gone up? How far has it risen? 4. So our gradient is 4. Are we clear with that? Do you want me to show you how to use the other equation? I'll give it to you, you can use whichever one you want, but the other equation works like this, right? I'm going to call Flynn's point, Flynn's coordinate, I'm going to call that coordinate 2. Happy with that? So Flynn's coordinate was 0, 4. I'm going to call that coordinate 2. So that's x2 and that's y2. I'm going to call Lani's coordinate 1. So Lani's coordinate was 1, 0. So that's going to be x1 and that's going to be y1. Cool. It's -1 though, isn't it? So now I put in y2 minus y1 over x2 minus x1, and all I do is I substitute my value in. So what is y2? What number is y2? 4. So I put 4 in place of y2. Minus what's y1? 0. Divided by what's x2? 0. Minus what's x1? -1. So what's, make that simple for me. What's 4 minus 0?
4.
What's 0 minus -1? Positive 1? So I get my answer in 4. Clear with that? So all that happens in this one is that I pick 2 points. As long as my x2 and my y2 are the same coordinate, and I follow that through the whole way through, and the same thing with my x1 and my y1, I don't make mistakes. They're doing exactly the same thing. It's exactly the same process. it just looks a bit funny. The reason why we do that is when we look at the red line, what's different about the red line here, Clyde?
Sorry, positive.
So our black line is going up this way, left to right is positive. What's our red line doing?
Negative.
It's going down, so it's going to be a negative gradient. So immediately in my head when I see it going down, I know it's going to be a negative gradient. We need to keep that in mind. But the same thing applies. Give me a point. Charlotte, give me a point on my red line. Any point, doesn't matter.
Negative 1, 5.
Negative 1, 5. So you're picking this point here. Give me another point on that red line, thanks, Lane. Any point, doesn't matter which one.
0, 3.
0, 3. These guys are picking very nice points for you. So again, same thing, I write my equation. Now what's the equation? M equals rise over run. What's my run? How far across have I gone? I started at -1, I finished at 0. How far across have I gone? 1. My run should almost always be positive. 1. What's my rise? How far up have I gone?
3. 8.
Tell me. I want the difference between these 2 points, correct? But what's the word? What's this word say?
Rise.
Is it rising?
Yeah, 2.
It's rising too, is it? How do we read?
It's not rising.
We read left to right, don't we? So is it rising?
No.
It's decreasing. So yes, the number is 2,
Negative 2.
but it should be -2. What's -2 divided by 1? -2. So our gradient is -2. And that there is why sometimes it's better to use this equation. Because providing we shove the numbers in correctly, providing we pick our coordinates, it doesn't matter. We won't ever make that mistake of going positive and negative. If you know you're good enough to look at it and go, that's a negative gradient straight up, or that's a positive gradient, and deal with it accordingly, use your rise over run. Are we happy? But if you find yourself making mistakes, come back to y2 minus y1 over x2 minus x1. Sweet? All good. I'm going to give you a chance to practice one more of those, and then we're going to check our homework, which is the answer on Google Classroom. I'm going to come around and fill out my sheet, and then we've got an education pedal.